From this video, you guys will be able to complete letters GHI in this worksheet and also the solve percent increase and percent decrease problems from the other handout, chapter 5B. So we're going to start reading from right here. Exponential functions can be used to model growth and decay problems. The rabbit problem in number 1 is an example of a growth problem because the number of rabbits is increasing. The iMac problem in number 2 is an example of a decay problem because the value of the iMac is decreasing. Percent increase problems are a type of growth problems. The common ratio is called the growth factor. Right, let's look at the problem now. Eric threw his dirty gym sock under his bed. The sock started with 9 milligrams of bacteria. After each week that passed, the amount of bacteria in the sock increases by 37%. For A, it says complete the table at the right. Do your values increase or decrease? So at week 0, U sub 0 is equal to, remember, U sub 0 is always the starting amount. So in this case, the sock started with 9 milligrams of bacteria. So we're going to put 9 here. And this G should be milligrams instead of grams. Now it says it increases by 37%. So what we're going to do is we're going to multiply 9 times 1.37. And you're going to get 12.33. And then multiply 12.33 times 1.37. And you're going to get 16.89. And then you multiply 16.89 by 1.37, and you'll get 23.14. So you can tell that the milligrams of bacteria increase. They go up from 9 to 12.33 to 16.89 to 23.14, and they keep increasing. For letter B, it says Mark thinks the growth factor is 0.37, but Laura says it is 1.37. Who is correct? Why? So Laura is going to be correct. Because if you multiplied 9 times 0.37, you're going to get a number that is smaller than 9. But it says increase. Because it says increase, we know that we want a number bigger than 9. So that's why it's going to be 1.37. In general, if it's going to be if it's increase, it's going to be 1 plus the percent. So in this case, 1 plus 0.37. If it says decrease, it's going to be 1. If it's a decrease by 37%, it's going to be 1 minus 0.37. recursive formula, u sub o is going to be equal to 9, right? This 9 right here. U sub n equals the term before it times 1.37. Right, how do we get the third term? We took the second term and multiplied it by 1.37, or we took 16.89 and multiplied it by 1.37. How do we get the second term? We took the first term, which is 12.33, and we multiplied it by 1.37 to give us 16.89. So this is saying any term equals the term before it times 1.37. In the video with the rabbits, we used R and T, but this time we're going to use B and W. B for bacteria, W for weeks. We're always going to put our u sub 0 first, which is 9. And then we're going to multiply it by our growth factor, which is 1.37. And the exponent is W. So this W and this W are the same. For letter E, by what percent is the bacteria increasing per each week? This is called the percent increase. So there's two ways of doing this. Is one, you can just look at what is to the right of the number 1, which is 0.37, and that's going to be 37%. Or, like you learned in a few years back, you can do the new minus the old over the old. You can always do that. You can pick any two consecutive terms. So you can do 12.33 minus 9, that's the old one, right? The one right before it, over the old one. And that'll give you 0.37, which is 37%. So you could do that with any two terms. So you could do 16.89 minus 12.33 divided by 12.33, and that would still give you 0.37. How does the percent increase relate to the growth factor? So the growth factor is 1.37, and the percent increase is 0.37. So it's 0.37 more than 1. Or we can say that it's 1. Sorry for the sloppy handwriting here. I'm going to work on getting a new pen. More than, and then this is a 1. Or we could say it's 1 plus and then 0.37. Go ahead and try G, H, and I using the explicit function.